Welcome to the Jones Seminar today. It is a pleasure to have Susannah Drake here to give a lecture to us. She is the founding and principal of DLANDstudio Architecture and Landscape Architecture. She is no stranger to Dartmouth College, having grown up here, I think, in the Upper Valley, her father being a professor at Dartmouth. She graduated with an AB from Dartmouth College. She, amongst her various educational and training endeavors, she received a Master's of Architecture and Master's of Landscape Architecture from the Harvard University Graduate School of Design. Her firm is internationally recognized as the recipient of city-state awards, as well as those from the American Society of Landscape Architects for their urban design and landscape architecture work. In 2014, DLANDstudios won the New Practices New York Award from the American Institute of Architects. In 2013, Susannah was awarded the American Institute of Architects Young Architects Award, Fellowship in the American Society of Landscape Architects, and recognized as an Architectural League Emerging Voice. Susannah is former president and trustee of the New York American Society of Landscape Architects and the Van Allen Institute. She's led design studio courses at Cooper Union, Harvard University, Syracuse, Washington University, and Florida International University. In 2015, she was invited to Middlebury College as the Cameron Visiting Architect. She's received numerous grants and awards for adapting infrastructure corridors for stormwater capture, climate resilience, park creation. She lectures globally about resilient urban infrastructure. DLANDstudio's public projects include Queensway, MoMA Rising Currents, BQ Green, and Gowanus Sponge Park. Her work is in the permanent collection of the Museum of Modern Art and the Cooper Hewitt National Design Museum. I would have to say, just as an editorial, we don't really get enough architecture talks here, and so it's a pleasure to have someone who can speak with such experience and authority, and really it's an absolute joy to have you here today, so thank you.
Thank you, Brian. I kind of work at the edge of different disciplines, and so I actually appreciate speaking at an engineering program because a lot of the work that I do involves sort of adapting engineering and thinking about how we can make cities more, as my title suggests, beautiful, economically productive, politically sort of engaged, and ecologically productive. So my work really, I think, creates kind of a new paradigm of design. When I got out of grad school, and I say this for the students in the room, I couldn't get a job. I had three Ivy League degrees, and I couldn't get a job in New York. And part of the reason was that I wanted to do interdisciplinary design. I was an architect and a landscape architect and had a liberal arts undergraduate degree. And they didn't know what to do with me. The architecture firm said, what do you want to be? Do you want to be an architect or a landscape architecture firm? There weren't a lot of landscape architects in New York at that time. And I needed to be there for various reasons. So I've kind of invented my own mode of practice, which has sort of caught on and become popular. But it's really the intersection of community, water, economy, climate, ecology, and infrastructure. And thinking about all of those things, looking for issues that need fixing in the city, and like basically making it up and making it happen. I feel like we're kind of urban inventors, and I actually come from a family of inventors, so I appreciate that idea. So a lot of the work that I do sort of thinks about politics and what has shaped the American landscape. And Thomas Jefferson had a huge impact on the American landscape with the development of the land ordinance grid, which created that kind of iconic patterning we see across the United States of dividing the country into territories, townships, and sections. 100 years later, and actually I should say that when Jefferson created this, he provided land or made land available for purchase. So if you had enough money to buy one of these sections, you could go out and own part of the United States. But you had to have all that money, and it was something like $600, which was a lot of money then. But what Lincoln did 100 years later was open up different opportunities for more different kinds of people. If you were the head of a household, you proved that you could make a piece of land productive, you could get lines of credit to own smaller parcels of land. And you could be African American, you could be a woman. As long as you were the head of the household, you could develop that land. And I think that's really sort of important in thinking about the shaping of this landscape, which, when you look at it, is a fairly regularized grid that's clearly been affected by technology with these circles that we see, which are irrigation circles. But you can also see that there's an intersection between the grid and the geographic systems, the natural systems that are running through this regularized system, such as, you can see these lines of water bodies, right? So another precedent that I want to raise in my sort of trajectory of thinking about politics and how it's affected the American landscape is FDR and his New Deal. And what the New Deal did through the Works Progress Administration was create a whole series of incredible parks across the country, but then also put people back to work during the Depression or after the Depression, creating these civic buildings across the United States, and also creating systems of infrastructure with the Tennessee Valley Authority, which brought power, jobs, flood control to rural communities, really transforming not only the shape of that landscape, but the economic structures of that landscape. And thinking about massive ecological change has been something I've been sort of stewing on for a long time. My dad was a professor here. He's a geophysicist, and he led the rock stretch for a number of years. And when I was 14, I got to go on the rock stretch with them, which was a pretty meaningful experience, I think, for a 14-year-old. And I started looking at these places. This image I drew when I was in grad school, and I did a study of dams in the Southwest. So it was related to that early childhood experience. But thinking about how the landscapes are so different on either side of these structures. So infrastructure as a term actually developed in the World War II era. It's a relatively recent term in reference to military logistical operations. And General Eisenhower, the great military leader, developed the federal highway system after that experience because he recognized that we didn't have a good way to move people around the country efficiently. So he put $25 billion into what was called the Federal Highway Defense System, and basically managed to push that forward politically because it was seen as a defense system, because it was accepted by a country that was wounded at the time. But it was also very much of a development system, kind of just like Jefferson and just like Lincoln, and in enabling people to get to a lot of places that they might not have been able to access before, and opening up this property to be developed, and for better or worse. Right? Unfortunately, some representatives actually still equate the building of more and more roads in that 1950s model to economic development. And so I have to sort of question some of that in my work.
The problem is, though, when our infrastructure is not being destroyed by robots and or saved by Bruce Willis, we tend to find it a bit boring.
As you know, infrastructure is not a sexy or glamorous topic.
As much as I'd like to think otherwise, infrastructure is not sexy.
Infrastructure is not very sexy.
Yes, infrastructure, like those men we just heard from, is important but not sexy.
So I love John Oliver. But what I'm trying to do is actually make infrastructure sexy and make it more productive and make it better for people on many more levels. And it's not necessarily a new idea because LBJ basically signed the Highway Beautification Act in 1965, the year I was born, to start to clean up the highways, to take down these billboards and make these highways more beautiful spaces, understanding that there's a huge impact on the American landscape. And so I've taken that idea and I've been thinking about how these larger scale infrastructure systems can affect a city. And this is a competition that we did and won for improving the transportation or the travel from the airport in Montreal into the city, or the center city. And of course, we were tasked with looking at Montreal, and we looked at all of North America, but So communication of really complicated information is actually a big component of what we do. And we worked with a company called Trollback on that video to sort of give our overall vision. Go forward, there we go. But, a big component of what we do thinks about the relationship of those roads to watersheds. And we do a lot of work with stormwater management. And part of the legislation that actually enables our work was signed into law by Richard Nixon. I have to say he has been probably the most meaningful president to the work that I do, believe it or not, because of the signing of the Clean Water and the Clean Air Act. But I do also have to give a shout out to a mayor, Mayor Bloomberg, because a lot of the work that we did, while not working directly for Bloomberg, I think was enabled by his vision, which was put forth in Plan YC about a greater and greener New York. So a lot of the principles that are embedded in that document we're actually carrying out today. So there are 772 cities, U.S. cities, that have combined sewer systems. So Thomas Crapper did not invent the flush toilet, but he popularized it. He was a plumber. And because of his popularizing of the flush toilet, there were a lot of issues with excess sewage effluent in Europe. And so the combined sewer was invented. And unfortunately, what that meant was that a lot of sewage effluent was discharged into nearby waterways. And what happens is, in a normal situation, the sewage effluent is just going into a treatment plant. You can see through this diagram that was, it's an environmental EPA diagram. But when the storm drainage is added to that, there's too much effluent in the system and it goes into our waterways. And so what I'm trying to do with this first project I'm going to talk about is to redirect that stormwater and absorb it in what I call the sponge park. I'm working in the Gowanus Canal area of Brooklyn. It's an industrial area where you had a swamp that was channelized over time to facilitate industry. And I'm going back in and trying to restore some of that original hydrology, trying to add permeable landscapes to this hardened landscape. And when I was thinking about this neighborhood, I wasn't about to go in and say to people, I'm putting a swamp in your backyard or I'm putting a wetland in your backyard. I said, we're going to put a sponge park in your neighborhood. And then people were really excited about it. And it was nice because kids got it, like everybody got it. They understood what the landscape was supposed to do. And we've taken on a sort of global problem of stormwater management with a lot of local pilots. And we work with a lot of grants, and the grants enable us to innovate because a lot of the public agencies have a certain fear of change. And part of that is that there's no reward for innovation within the public sector, unless, if you have a mayor like Bloomberg, but you don't always have mayors like Bloomberg. So we applied for these grants that enabled pilots to push some of the ideas forward. And the Sponge Park is a sort of interesting model on that because we also worked with a lot of different community organizations that don't like each other. And we worked with a lot of agencies that don't usually work together and had to through the project. So we created this incredible consensus in this very kind of Machiavellian way by bringing in all this money and then saying, here's this project that everybody's behind. And so, you know what, guys, you just have to get along. But this is the site. It's the Gowanus Canal. It has a very degraded edge. And that shipping container here, believe it or not, is a place where there are canoes stored and kayaks. It's the boathouse for the Gowanus dredgers. And they access the water here. This EPA Superfund site they access to go canoeing. But here you can see the problem that all of this water has nowhere to go when you have a heavy rain. And this happens far too frequently. And what it does is it brings a lot of that polluted effluent down to the water's edge. So some of it's entering the combined sewers, and some of it's just carrying all that detritus to the street end. This is actually raw sewage sitting on the top of the Gowanus Canal because of the combined sewer overflows. So this is not a third world country. This is New York City. And it really shouldn't be this way. So we're working to affect change. So we did a lot of work in section trying to think about that former hydrology and how we could restore that permeability, but how we could also add public open space on top of a landscape that was absorptive. So we came up with a lot of different programs. In this case, we have a walkway that's kind of floating over a continuous hydrologic system. And we created new boathouses and new cafes and those kinds of things in our overall master plan. This is the street end Sponge Park at Sackett Street, for example. The city planning was undergoing a rezoning of the area when we started working, and so we convinced them that 40 feet would be a more sensible setback than 20 feet, so we'd have more landscape to work with. But we also pointed out to them that all these black marks on this map, those are places where the buildings actually abut the industrial canal, because of course they would. You want to drive your boat up and offload directly into the building. You don't want to offload into a dock and then into another building, right? So we thought that was actually an important part of the historical past. And so we thought rather than calling for that to be eliminated over time, let's keep it and think about how we might create this urban promenade that brings people back into the neighborhood and in that way actually improves the value of the upland spaces as well to create this entire green district. And these pathways, we weren't going to paint them yellow. That's just for graphics so you can see it. But the idea was that you'd have these productive landscapes that would stretch back with new trees and open spaces, and that it would create connections to some of the existing open spaces as well. Now, working in New York City is really complicated, and I know everybody thinks their landscape is the most complicated and the most political anywhere, but I have to believe that this is a little bit special because if you just look at this diagram, this is a cross-section of the Gowanus. The sediment underneath the canal is controlled by the Army Corps of Engineers, and it's also a navigable waterway, so we have to be cognizant of that. But now it's an EPA Superfund site, so the EPA Superfund people are also involved, and they're slightly different than the Army Corps. The first 5 feet of soil in the upland area is controlled by the Department of Environmental Conservation, which is a state agency, and because it's a brownfield, and so they have very particular regulations about how we work there. The surface of the ground is controlled by the Department of Transportation because they're technically the landowner, that agency. Then anything green belongs to the Parks Department, so because they're going to ultimately be maintaining it, and they don't really want to take on new assets, as they call them, because then they're going to have more responsibility for maintaining, and they don't have a budget for maintenance. Like, they don't have a dedicated budget for maintenance. How stupid is that, right? This is recorded, right? Right? Maybe it'll get back to Diana Taylor or something. Anyway, and then the water that flows over the ground is actually controlled by the Department of Environmental Protection, which is a city agency. Then there are setbacks, which are set forth by city planning. And our former city planning chair was very keen on being an urban designer. She is an urban designer as well. So she created zoning regulations that are more like design guidelines that call for a particular amount of shade, particular amount of seating. The seating has to have backs. There are a lot of restrictions within that. And then even right here, you can see this little protrusion, this little walkway that sticks out. The shade over the water is also controlled by a state agency, the Department of Environmental Conservation. So it's just insane how regulated it is. It takes, I think there are 200 permits we had to get for our first project, and it's taken 8 years to get all of the permits in place. And I joke that it was like 8 years in approvals and 8 weeks in construction, because I designed it in a modular way so it could roll out really quickly so nobody could say no in the middle, right? So, and I'll tell you a story about that in a minute. We're also working across the way in a cultural redevelopment, this big old building that's being turned into a new arts center. So it's kind of fun to be working in the whole area and starting to make change on a broader scale. But this first project we've built now is this pilot, and this is where the engineering, part of the engineering comes in, some of the civil engineering, because what we did was we calculated the amount of water that was flowing down the streets, and we found the street that had the most, and we figured this is the worst case scenario, so let's work on that one. And we calculated the amount of water for the 1.2-inch storm, which is a state regulation, and that's 90% of all storms that happened in New York City last year. So we're not designing for those really super extreme ones, but we're designing for most storms. And we worked within that 40-foot setback that was set forth by city planning in the rezoning. And we also had to get the approval of an organization called the Public Design Commission, and they work outside of the agency process, and they're really kind of the design police for New York. And so we talked to them about the existing streetscape materials. These are the street ends in Gowanus, and how there isn't really a pattern. Right? You can see there's asphalt, there's cobble, there's some green, but it's not really a discernible pattern. And so when we proposed our new pilot street end, we said, okay, here's what we're proposing, and this is what the existing was, and really we're just reconfiguring, right? And so the Public Design Commission was like, yeah, this is great. And this is how it works. So that's the existing condition. These are what they call green streets. They're planting beds that don't have any ability for the water to get into them other than coming from the sky. So we're taking those out. We're putting in these street swales in the upland areas. And then we built these bioretention cells. These are all precast concrete, and they're interconnected. And then in the middle part, in the top part, there's an integrated sidewalk and sedimentation basin. What that does is it takes all the water that's coming down the street and it filters out all the larger particulate matter and actually some of the fine silts. And then there's a pedestrian path over a sand filter and a drain. So when it rains, the water comes down the street, and a lot of it is caught by the upland basins. And we're actually now in a process of maybe expanding that technology as well. But it goes into this sedimentation basin, and then the water gets distributed evenly to the cells, so that the plants, you don't get some plants that are over-irrigated and some that are under-irrigated. And then if it rains a lot, like if we get above the 1.2-inch storm, we also designed a sort of fail-safe or a sort of extra capacity where it'll go into the sand filter and then discharge into the Gowanus Canal. So that's the basis of how it's working. And one of the things I've found with a lot of these, this is actually it in construction. And, the contractors tried to push back with doing this as a precast system because it's a pretty huge basin. But at the same time, I just really needed to control the construction quality, and I also wanted to make the rollout of the project, the construction on site, really short. And it turned out that was a really good thing because this site is also tidally influenced. So every day they would have to work around the tide calendar because the water would fill up the excavated hole, and then it would lower down. I didn't tell this in the earlier lecture. But so, they have their tide calendar out, and they're like planning all of their construction around that as well. So it turned out that having this be modular was good. Also because you wouldn't have time to allow the concrete to cure, right? So it all made a lot of sense. So this is it in construction. I don't have the fully built one, but here you can see the sedimentation basin, and we ended up taking out the walls in between the cells because we really didn't need it, and we figured why have it if we don't need it. So this is the soils going in, and this is the sand filter. There's actually a walkway that goes on top of this that is built now, but I don't have a picture of it. But this is it as of October 21st. It's now constructed. It'll open officially in the spring. So very excited. 8 years and 8 weeks. So there are 7,200 miles of bridges and elevated highways that run through U.S. cities. And I've been looking at this issue for a long time in New York, where there are 666 miles of elevated structures. And this map actually showing the relationship between open space and population density. So you can see there's some places where you have pretty dense population that needs open space and happens to be next to elevated infrastructure. So for the last year, actually 2 years ago, I was the Urban Design Fellow for the Design Trust for Public Space, and we developed 7 different typologies of methods for improving these spaces under the elevated. They're all around New York City in the 5 boroughs, although we didn't include Staten Island because it doesn't have a lot of elevateds. But We have one we called clover, which is the classic, what do you do with a clover leaf of highways, landing where bridges land, train where you have a really noisy landscape underneath a train trestle, car where you have a big highway over really sheltering a lot of space, one that was in a park, one that we called span because you had something on either side, and then cluster, which was where you have a lot of different modes of infrastructure coming together. And then we also looked at the age of the infrastructure and when it might become obsolete or need significant repair, because that might help the agency strategize where they're going to do their next intervention, how they might improve the piece of infrastructure where they're working. Or where they're scheduled to work next or need to work next. So we looked at the Gowanus Expressway in Brooklyn and thought about how there's all this space underneath the expressway that's currently only used for parking. And so we thought, well, we could actually use that for green infrastructure and then also to take the water off of the raised highway and then also potentially use it for maybe some outdoor workshop space, because a lot of the artists and the industrial functions that used to be in the Gowanus area are getting displaced because the area is getting gentrified and developed. And then we thought, well, ultimately you could have more permanent studios in that space and more permanent green infrastructure, because the area is also at the bottom of a hill, and create like an actual usable public space. We also looked at Broadway Junction, which is at the intersection of MTA and a bunch of roads and elevated train lines, and also some underground train lines, and thought one of the biggest issues there is wayfinding. It's hard to understand where you are. So we created this new public space, a sort of larger collector space, where with some coding on the columns, so you could understand sort of which direction you were going. If you're walking, blue might be north, or I guess green should be north, right? But starting to think about how an incorporation of public art might help with the wayfinding, and then there would also be some green infrastructure elements as well to make it into a public space. This is a project up in the Bronx that we did with a grant from NOAA, working with the Bronx Center for Environmental Quality on a pop-up project. But part of the issue with these elevateds is they release a lot of storm water through these scuppers. All the water collects on the elevateds, and then it goes down these downspouts. And a lot of times it doesn't even go into a catch basin. It just goes directly out into the neighborhood, like that last slide you saw. And that's a public health problem, because not only does it breed mosquitoes, but there's also a lot of biological, issues in it. So I got a grant from the DEP, Department of Environmental Protection, to do a couple of innovative prototypes as well. So we have the NOAA project and then these. And what these are is we call a system we call holds. So it's creating a sedimentation area and then an absorption basin, like a modular bioswale. And this was the first prototype, which is in-ground. It's out in Flushing Meadows Park. It's an area that has very low permeability. We built this. This is where I decided that I always needed to use precast, because I let the contractor not use precast and the construction quality wasn't good enough. But we had that one, which is the concrete cell, and then we had this other one, which was made with gabions. And I got a call from National Geographic, I think, middle of last week, and they wanted me to talk about the urban wildlife. And they were talking about that coyote in Central Park, which actually I was there when the coyote showed up. It was really wild, at least the first time. And my daughter, who's now a freshman here, was like this high, so it's kind of funny to put that in context. But we built this, and this muskrat, not this particular muskrat, but a muskrat moved in, because we designed, in each of our green infrastructure systems, we're designing monitoring. And there's a housing for that monitoring, and it turns out it was like the perfect condo for this muskrat, because the monitoring vault has an angle that for drainage, which is exactly the same angle that a muskrat would build for themselves when they're building their layers. So he moved in, and he started chewing up our monitoring equipment and leaving all his candy wrappers and things around. So he wasn't a good citizen. So we ended up having to kick him out, and we didn't bring in bobcats. That's just there for scale. But that was sort of like evocative. These muskrats are huge. The first time we saw it, we thought it was an actual rat. Actually, I thought it might be a beaver, but it was a muskrat because they have the skinny tails. So there are 35 million U.S. residents that live within 100 meters of a 4-lane highway. When I first started the firm 10 years ago, I had this vision of capping the Brooklyn-Queens Expressway. I got a grant from the New York State Council on the Arts to develop some ideas, which then captured the interest of a city councilman in another area of the city. But part of my thinking was to start to quantify the benefits of environmental intervention. And so we used this data provided by the U.S. Forest Service. There was this like huge tome that was really boring, but it was all about the value of trees. But it wasn't presented in a kind of easy to digest graphic form. It was, a lot of descriptions. But I had a really brilliant woman working for me who managed to translate it into this wonderful diagram, basically showing in one page that you could get a $50 million gain from the planting of these 350 trees. And you get that gain in oxygen production and pollution control, recycling of water, and shade value. One of the students, I gave a version of this lecture earlier, and one of the students asked what I meant by shade value, so I'll explain. It's basically the cooling of those surfaces. So it's not increasing the albedo of the surface, but it's keeping the dark surface shaded so that it's not adding to the heat gain. So a lot of the landscapes that I work with, particularly the Brooklyn-Queens Expressway, were created by Robert Moses. And he did a lot of good things. He created parks, he created playgrounds and parkways, a lot of great things. But he also created landscapes like this. This is actually the Cross Bronx Expressway. And so what I'm trying to do is actually, soften those projects. Because I think when he first started out, he actually had a fairly good heart because, he presented images like this, which I call bait because what he ultimately gave us was a switch. Robert Moses, spent a lot of time looking down at it, watching the cranes and derricks and earth-moving machines that looked like toys far below him, moving about in the giant trench being cut through mile after mile of densely packed houses, a big black figure against the sunset in the late afternoon, like a giant gazing down on the giant road he was molding. That's from The Power Broker by Robert Caro, and it's kind of an incredible description because Moses actually had this hotel in the Bossert, or a room in the Bossert Hotel, which did look down on this trench, and this is what he saw. And these are the derricks, cutting through the brownstone neighborhood. Now, granted, it wasn't the sort of Tony brownstone neighborhood it is now, but it was still, a lot of sort of nice housing stock that is gone. So, as I said, this got the interest of a city council person who is now the borough president, or the deputy borough president nearby in Les Souris, which is a relatively low-income neighborhood, a little bit up the road in Brooklyn, in Williamsburg. And in that case, there are these physical boundaries of the infrastructure that are impacting the neighborhood. And it's important to note that this section of the BQE was built in 1950, so it's really nearing the end of its lifespan. It's an area that is unfortunately plagued by a lot of gang violence. Diana Reyna, the city council person, now borough president, or deputy borough president, she was actually caught she wasn't killed or hurt, but she had to duck behind a water fountain when she was a kid because there were gangs, the Puerto Rican gangs on one side and the Dominican gangs on the other were having a fight, a gunfight. And so she remembers that very viscerally and wants to make change. And this is an area that has significant public health issues, high asthma rates, low physical activity, and really high neighborhood poverty. So it's also an active recreation desert, which is a real problem. It has tot lots, but it doesn't have a space for the kind of teenage kids who might be getting involved with the gangs. So through a number of neighborhood meetings, what we recognized was that what the neighborhood wanted was to build new playing fields, to make this a really vital open space at the heart of their community. And we did that by capping the BQE. And we had to look at the structural feasibility of this and recognize that in the northern sections of what would become the park, we could do this fairly easily by putting in an intermediate structure. But in the southern part, between South 5th and Broadway, it didn't work. And the reason that that was important is that we had to bring the highway up to federal highway standards if we were going to make a change. And that meant we needed to have 16 feet of clearance. And that meant that we needed to keep that structure fairly thin. And we're putting a park on top of it, so that requires a pretty heavy structure. So what we did was put field turf over the center because they wanted playing fields, and then put some of the heavier big trees over on the sides, but also managed to keep the deck pretty thin with these intermediate columns. So this is the overall design. So you can see how the trees are kind of on the sides, and then the field turf is in the center. So this is what I like to call an existing economy. You have these bridges, and they are really at the end of their lifespan. They're going to cost about $10 million a piece to replace. So I thought, why not create an enabled economy where we take these bridges, replace them, and use that as a local match, filling in between with federal, state, or private funding to enable this park to happen. This is a fairly passive, passive because there's nobody there, passive open space that exists now and how we want to activate it. So there are 20,000 miles of rail trails in the United States, and the Queensway is adding another 3.5 miles. We're working on this project that runs through the heart of Queens with the Trust for Public Land and an organization called the Friends of the Queensway. It adds 3.5 miles of trail, 47 acres of parkland, 40 acres of which are currently underutilized DCAS property, and then there's another 7 acres that are currently owned by the Parks Department. This is the current condition. It's completely overgrown, but it can look like this. This is actually the same place, but in a different section where it's just this incredibly beautiful woodland. We divided it up into different pieces because there really are a lot of different strategies that are needed. It's not like the High Line where it's all just one raised, elevated park, and you can come up with a whole sort of standard series of design moves for it. The places are very different, and they have very different neighboring conditions as well. It's CB9 and CB10 are the most diverse in the city. And there are 322,000 people that live within a 20-minute walk or a mile of this future park. We looked at different kinds of programming that related to the desires of the different neighborhoods. And then really started to look at the existing conditions in sort of 3 sections, because the northern section is on a mound. The center section is what looks like in a valley, and the final section, the south section, is on an elevated. And part of the reason that this topography exists, particularly the center part, is that it's cutting through the terminal moraine of the Wisconsin Glacier. So it seems like you're going through some ravine, but you're actually just cutting through the big pile of sand that was left by the last glacial epoch. So a lot of what we're doing is actually an editing, going in and making better connections to some of the neighboring uses, so making a better connection to the Little League fields, improving the accessibility of the area that's in that ravine, in that park space, and then also really cleaning up and making accessible this elevated part. It's sort of I like to call it the sort of parks for the people. So this is on the northern end, creating an ecological and cultural landscape where we're drawing upon the geology and the culture in building these stone walls. A lot of the early boundaries of the properties were made by stone because of all the glacial till that was left behind. You know, you have a resource and you use it and you make a wall. That's why we have so many stone walls up here, right? So we wanted to use that idea and bring back that sort of cultural legacy and also that geologic legacy, and then also brought back the enhanced stormwater management, allowing the water from the whole sort of bowl that's around it to filter into this site. We looked at sort of capitalizing on neglect. One of the things that you can't buy is time in the landscape, and we have trees there that have grown for the last 50 years, and they're big, which is so nice because we don't have to plant little trees and wait for them to grow. They're already there. We just need to clean out all the poison ivy and the Japanese knotweed and put in some seeding so that you can actually access this site and watch your kids play Little League in the shade without having to build some big shade structure. So we're capitalizing on that neglect. And then also really looking at people and the relationship to the existing homeowners. The people are very sensitive about building something new. And so we're trying to enhance the ecology of this section so that more screening can occur, but then also trying to leave it open enough so that you don't feel vulnerable when you're on that park. Oops. So here's just a detail of that. In some places, we actually agreed to create new privacy fencing for the residents as well. We have two pathways, one for bikes that are going really fast and one for pedestrians that are moving more slowly. And then also thinking about year-round uses of Forest Park. This would be great for this weekend when we get the blizzard. Everybody could be out there, but we're adding things like this is the red twig dogwood and adding more evergreens to make it a really beautiful winter landscape as well. And then thinking also about how we have an educational opportunity with the school that's right next door and creating places where the kids can learn outside to create this urban greenway that we like to say is for real New Yorkers. It's really for the neighborhood and for people of New York City, not just for tourists. So 40% of the world's population lives within 100 kilometers of the coast. And in 2010, my firm, DLANDstudio, partnered with our ARO, Architecture Research Office, to do an exhibition for the Museum of Modern Art. There were 5 teams that were asked to look at different scenarios of how to improve the resilience of the city in the face of a potential storm and climate change. We were looking at a 6-foot sea level rise. This is actually a map showing potential inundation in a Category 2 storm. So we started by looking at the history of the city and the shape of the landscape, and you can see that there's been a tremendous transformation over the last few hundred years, from this edge that really didn't facilitate shipping very easily to a hardened edge so that you could have that exchange of goods to, these finger piers for larger boats. But now, recreation and residential use are really the highest and best use of the waterfront, so we have another different shape. But the hydrologic conditions that existed in 1845 exist today, and the lowland is still lowland, and the swamps are still there, but they've been channelized. But they kind of want to come back, and that's been a sort of theme of a lot of my work. It's like I don't mess with Mother Nature. So this is a map showing the value at risk. This is the area that would be inundated by a 6-foot sea level rise and then an 18-foot Category 2 storm surge. So you can see, it's tremendously valuable real estate, and it's the middle of our whole sort of financial center, the world, the stock exchange is in there. It's kind of important that it be protected. And so this is the existing seawall in 2010, and this is it with a 6-foot sea level rise by 2100, so it's not that far away. And then this is it with a Category 2 storm inundation. Now, again, we did this in 2010. And this are existing combined sewer overflows. So our thought was, let's think about how, if the water comes in, how do we get it out? And if the water's coming from the sky, if we have a big storm like we had with Irene, how do you get that water out? So we created this new urban ground. So the thinking was to create new urban infrastructure in the upland areas, create absorptive streets. 27% of the city of New York is paved with streets. So we thought, if you make them all permeable, you're going to go a long way toward helping with your CSO issues. And I wanted to put all of the infrastructure into the sidewalks in waterproof vaults that you could then access with some kind of hatch. So if it became obsolete, you could just replace it instead of ripping up the street all the time. Then we had level 2 streets for distribution and collection. They basically could hold a lot more water. So it's a slightly different section with more capacity. And then level 3 streets for protection. So this is for the case where you get a big storm surge and you need a place to store all that water until the tide goes out or until the storm dissipates. So there were larger retention areas underneath some of the broader avenues to hold that water. And then just more of this open green space to also absorb more. So that creates a whole porous green street system. And then we have a new 6-foot hardened edge. So what we're proposing is to actually raise the grade by 6 feet and then add new waterfront parks, new freshwater wetlands, and new salt marshes. And our freshwater parks were designed, we quantified it so that we were absorbing, again, the 1.2-inch storm. So we were trying to be sort of strategic about how much we were creating. And the overall result is this new resilient system. And, it's an urban design issue. So you're creating these new kinds of edge conditions that can also integrate with new urban buildings, right? You could have new towers, but there's a waterway that's actually coming through. Maybe you end up having more boat traffic. And then along the edge, you make a new place where you might be able to go canoeing or kayaking off of the edge of Manhattan in the shallows, still allowing for ferry traffic on either side. But that would provide a breakwater for big storm surge, dissipating the period of the waves. And then over on the east side, thinking about creating the East River esker and breakwater. Can you tell I'm the child of a geologist? And with this geologic formation, that's basically a big berm, a big mound, that would provide open space on the outbound side, but then also the space on the inbound side that we call the sponge slips. So the places where you had the historic slips, which were for the exchange of goods, become a place of ecological exchange to create a new resilient city. So we did this in 2010, and we tried to get the city really involved. And I ended up teaching a studio up at Harvard with Stephen Cassell from ARO. And we did manage to get people thinking about it a lot more. We presented the students' work and this work to the commissioners of different agencies. But unless you have a disaster, it's hard to make things happen. But then we had a disaster 2 years later. And it was funny, I was up here for Irene, and I rushed back home thinking, I've got to get back for the storm, and then the storm hit here, and my sister was stranded in Stratford for a while. But anyway, so we had this big storm, and it basically put the lights out in lower Manhattan for a long time and caused a lot of economic loss, and a lot of people were affected. And so the city initially, the Dutch come out and say, oh, wait, we've got to put in big dams. And so there were proposals to put in these gigantic dams like this hard infrastructure. And, that's fine. There's a place for that. It's important. And, the traditional methods work for a while until they don't. And then they break. And so my feeling, actually before Sandy, but after MoMA, was that maybe we should start thinking about hybrid systems where we're combining the natural and the constructed to make a system that would grow in strength over time. So if you have an engineered system that, like say your engineered system has a particular level of strength, if you then add to it a landscape system that might improve its strength over time, you have something that doesn't just maintain or go down over time. It may actually improve in its value over time, and its value in relation to its protective services, as it were. So I also started looking at property values in New York, thinking about, well, maybe we need to have an idea about moving away from some of these waterfront spaces. And thought about something that I called, or developed something I called zone air, which was an idea for moving people away from some of these vulnerable areas and maybe providing an upzoning for some of the more vulnerable or more valuable areas that then provides a fund to maintain those edges. So you're creating an ongoing system for the maintenance of a landscape, which is something that's really, I think, needed not only probably at the city, state, and federal level. So thinking about how that might work, we then got involved with this organization, or with this project called Marshes, which creates the first wetland mitigation bank in New York City. So it's actually very similar to what I'm talking about, because what it's doing is creating a financial instrument out of a landscape intervention. It's taking this degraded landscape and improving it to be this, but then saying, okay, this has a value. Each acre of this, or each square foot of this, has a particular value. So if you're going to do something in one part of the city that might be doing harm, you can buy credits in this. And that's important because some of the places where you might be trying to put in a flood barrier that on some levels may have a negative impact on the environment, you may you may need this kind of offset in order to make it a reality. So we also, after Sandy, were involved with the New York Rising project, which was looking at how to protect some suburban neighborhoods from flooding. And so we developed these new landscapes that would have sort of greater topography and more open space to take that water. But it's really a global issue, and it's just going to increase as a problem over time. And so we wanted to look at the ecological structures and how they differ across the world, from reef ecologies to mangrove ecologies, maritime forest ecologies, and think about how these landscapes need to be reshaped. And in some cases, it had to do also with economics, because the Nile River Delta is a particularly significant place to look at, because this graphic is actually showing the inundation with salt water. So if you have an economy that's based on agriculture, and that agriculture is not for export, this local economy is going to be impacted in such a way that it's going to be starved. And so there probably needs to be a shift in how that landscape is used. I'm trying to think proactively. So how do you change this landscape to maybe think about how you create an export economy? Maybe it's biofuel, maybe it's different, like we were talking about using rice, different kinds of crops. And I don't know what they are necessarily at this point, but floating fish cages. But really changing the way this landscape is used so that in the future people have a livelihood and people have a way to eat in that area. But we also looked at the economies of New York, industry, finance, this is Shanghai, tourism in Miami, and informal settlements in Bangladesh, and tried to think about how we might reshape those landscapes. These were just kind of little snapshots of ideas that we develop in the office, because I have a lot of really smart people and we like to research and think about things. So they weren't really for a client, they were just to enrich our research. But the Miami one is kind of interesting. This is Miami Beach, and it's clearly a tourist economy. So we thought, well, we could redevelop that edge landscape in such a way that doesn't necessarily have to impact the tourist economy. Because we looked from the ground floor of the hotels, you couldn't really see the ocean anyway. So we thought, well, let's reshape that whole landscape to make it a buffer that can actually start to absorb some of that water, create breakwaters in this outbound area, start to add some topography to the beach, and create walkways across a mangrove ecology. And then also have a floodgate for just in case that also has a green edge. So that might have a programmed edge on the city side so that it's not just a big blank wall. So it's a dual function kind of barrier. So that was something we were working on as well. And actually, one thing to take note of, especially all of you engineers who may be able to figure out the solution to this over time, is that Miami is actually sitting on a giant bed of limestone, and so it's like a big sponge. So you have the salt water that's coming in from the ocean, and you have the fresh water from the Everglades, and there's just a tiny amount of topography in between. And it's really in a very, very delicate place. But meanwhile, there's just rampant development happening all over the area. And it's probably good that it's happening fast, because it may not be there that long. Well, that's terrible. But it's really a vulnerable landscape. So if we can figure out the solution to how you can keep the salt on one side and the fresh on the other, you'd be going a long way to solve a lot of Miami's issues and Florida's issues in general. So there are 39 million acres of roads and parking lots in the U.S., and to give you an idea of what that is, it's Georgia. I calculated that before lecturing at Georgia Tech. I said your entire state is equivalent to the amount of roads and parking lots we have in the U.S. But, music break. Business message.
gone. The keys to life, put up a parking lot.
Okay, there's 2 projects left, and this is one. And it's a parking lot. And it's in St. Louis. It's in the Grand Center of St. Louis, which is an area that's kind of an emerging arts district. And we designed what's called the Public Media Commons, and it's between the public television station and the public radio station, and then the Sheldon Performance Center and Art Museum is up here. It's a pretty wonderful site, but it was very underutilized. As you could see, it was a parking lot, and we transformed it into a new public open space. If you look at these buildings, they're really ugly. And we covered them up with giant screens that provide this kind of media experience and really provide constant broadcasting from the public television. So you end up with like Big Bird on the wall, although probably not anymore because that's not public anymore. But then there was a more sort of intimate video experience that you could have with these individual kiosks. There was a fashion show that happened. It's used all the time, and it's so exciting to see this place come alive. We have plantings that have year-round interest, and we have these wall plantings to cover up some of the sort of slightly harsher conditions of the new radio building that actually they somehow didn't anticipate, so that was sort of a later addition. But you can see what we were trying to do is play with actually an RGB palette, thinking about sort of digital media. And here are just some images of that project, and it actually won an ASLA award, and it's on the cover of the magazine in November. So we're kind of proud of that one. We're proud of all of our projects. We love all of our children. But and then this is the last project. So will alternate forms of food production change our views of farming? So I used to be really sort of vertical farm until I started working on the American Pavilion for the Milan Expo, and thinking back to that land ordinance grid and how it's shaped the American landscape. But then what these drawings show is like this is a very regularized grid, but then there are these geographic systems that have altered that grid. And so we wanted to reflect that in relation to some of the ideas about food now. Like if you read Dan Barber's work and think about the relationship between the flavor of different foods and where they're grown, or what an animal eats and then how it tastes. We wanted to start to think about all of those issues and reflect that thinking in this wall, and then also consider heritage crops, and also think about new markets for new different kinds of vegetables. So we worked with architect Jim Bieber. He was the architect of the whole pavilion building, and we developed this vertical farm that is the size of a football field. It's pretty huge. It has 50 different kinds of fruits and vegetables, and it produces about 5,000 pounds of food or produce per week. It does so on these things called zip towers, which are these extrusions that have a kind of foam in them and a little wick and an irrigation feed on the top. And you can grow incredible amounts of food with them. But they're also kind of magical as these kind of louvered screens for the interior space. So we turned something that's really an agricultural product into something that was an architectural element for the building. These panels are all on movable louvers too. So when you're at the expo, or if you were at the expo over the summer, you'd see this wall kind of undulate over on a timer. It was really beautiful. But it's also kind of funny to see, I think this one's kohlrabi. It's kind of like very shaggy and strange. We had to think about what kinds of things you could grow on a wall. Like you don't want to do big tomatoes that might fall on somebody's head, or you're not going to do pumpkins, things like that. So it was really a fun project to work on. These are the last 2 slides, but this guy, Nate Story, who's an agronomist out of the University of Wyoming, he's the inventor of the system. And he told me 2 really funny stories, or 2 really meaningful stories. One was a story about this guy, what's his first name? It's Christensen. His last name is Christensen. And he's this young farmer, and he had a little greenhouse. We went and visited his greenhouse. And basically this guy, he's like the 13th child of a farm family, and he wants to be a farmer. And, you know, the quarter section only goes so far when you're dividing it up, and that's not the way agriculture works anymore. So, you know, the price of land he was in suburban Denver, was too high for him to buy a field, but he could get a little greenhouse. So he got a little greenhouse, and he's using Nate's system. And what it is this is actually like a water base for the tower, so that the tower can sit in there, and then there's a feed allowing the water to go up a little, and there's a pump, integrated pump in this. And what this guy can do, Mr. Christensen, is take the tower to the Whole Foods and plug it into one of these bases. And what that does is it actually reduces his packaging costs, because it turns out for small farmers, I think something like 60% of their costs are in packaging of the vegetables and the fruits. So he eliminates all of that. And when you go to your Whole Foods, you can't get fresher food because you're clipping they give you scissors and you clip your kale right off of the tower. You clip your basil however much you need. So it's pretty interesting. But he also told another really funny story about mint, which is why this is titled Mint, because apparently he has a really, really good client in Miami. You probably know where this is going. So he has this client that uses thousands and thousands of pounds of mint every week. And so he really needed a greenhouse with this technology because apparently mint doesn't grow very well in Miami, and he had to do it year round. And so he bought these zip towers and is producing all of his mint for mojitos. So he's following the market, and I think that's a really sort of, it's an interesting sort of way to wrap it all up. It's you start with the market of selling off the United States, and then we end up with the market of selling our mojitos. So thank you. I'm happy to take questions, but I appreciate all of your attention for so long.